Hello, everyone. Welcome to Kubernetes Data Management YouTube channel. Today, I'm going to show you how to migrate the containers from a Red Hat OpenShift 3.11 to 4.x. Let's get started. Previously, I actually already recorded multiple videos talking about container migrations, how to move a small application from one cluster to the other in about 3 minutes. Today, we're going to focus on Red Hat OpenShift 3.11 to 4.x. So first of all, we need to set up the demo lab. I'm actually built the whole demo lab from AWS Cloud. So first of all, I need to build an OpenShift container platform 3.11 as a source cluster on AWS Cloud. So if you don't have a OCP 3.11, you can follow the link to build a OCP cluster by yourself. And secondly, you need to build the OCP 4.x as a target cluster running also on AWS Cloud. I got the YouTube link here, so you can watch the YouTube link, YouTube video to say how to build a OCP 4.x cluster. And then once you have the source cluster and target cluster up running, you can enable the container backups. Typically, you only need 3 minutes to enable the container backups. I got another YouTube video here to show you how to enable container backups. And then after that, so you probably need to clone the automation source code from my GitHub repository. There are a lot of codes I'm going to show you here. It was from my GitHub page. And last but not least, we need to have a common S3 bucket for the purpose of the migration. So it will need, this S3 bucket needs to be accessed by both the source and the target cluster. Here is a diagram to show you how it works. For my case, I built a 3.11 running on AWS Cloud. By the way, it's a self-managed OpenShift. It's not a ROSA, okay? Back to 3.11 times, ROSA wasn't born yet. And I also built an OpenShift container platform running on 4.7, also self-managed OpenShift cluster running on AWS Cloud. So on the left-hand side, you can see I got my MySQL database applications running here, including all the resources, objects supporting the application. So in this case, I was using Gluster FS as a storage. But technically, you can use other storage too. And I have Kasten K10. That's the tool we are using here to migrate the containers. In this case, MySQL from 3.11 to 4.7. So first of all, from a source cluster, we need to configure backup export policy. Basically, the snapshot backup, we're going to take a snapshot of your application components, your Kubernetes configurations, and your data. And after that snapshot has been taken, we will send another copy to the object storage. It can be any NFS storage or S3 compatible. In this case, since the whole lab are built on top of AWS Cloud, I might just use Amazon S3. Once the export copy to Amazon S3 finished, we will do an import job from my target cluster. In this case, I also have Kasten K10 deployed. We're going to create import policy. Part of the import, we will allow it to read the data from Amazon S3. After the import finish, we will do a restore job. After the restore job finish, basically all the components, all the spec artifacts, all these resources to support your MySQL application will be up running from the target cluster. Basically, on the high level, basically 2 high-level steps to make it happen, to migrate MySQL from a source cluster OCP 3.11 to target cluster 4.7. You configure backup export policy from a source cluster, and then you configure import restore policy from the target cluster. But very importantly, you need to create a location profile pointing to the same storage bucket. Okay, technically, it's for smaller application, you only need like 3 minutes. We can move the application from 3.11 to 4.7. It doesn't have to be 4.7, but for my case, I was building the OCP cluster, the target cluster running on 4.7. But I never tried, other Kubernetes, other OpenShift version yet. But 4.7, that's the one I used for this particular, demo. Let me come back to the cloud. Come back to my source cluster. So you might notice this is my OpenShift container platform that's running 3.11. And I also have a Kasten Documentation installed. I did a search of the project Yong. I don't see anything yet. So what I'm going to do first is I'm going to deploy a sample database application, which is called MySQL. And if I do the same search from our Kasten Web Console on the applications, you can search Yong. There's nothing else you can find. So first of all, let me deploy a sample application. Before I deploy this MySQL application, what I'm going to show you here is you can see this is running 1.11 from my source cluster. Basically, that's the cluster I created yesterday. That's the equivalent version 3.11. And then you can see my storage class, my default storage class is class FS. And if I do namespace list grep Yong, I can't find anything. That's my source cluster. Now let me deploy a sample database. I'm going to run this command here. By the way, all the command can be found from my GitHub page. I will show you shortly. Actually, my jump host already logged out. Let me log into the jump host first. I'm going to pause here. Okay, I just logged it back to my jump host. In this case, now I'm going to deploy a sample application, MySQL deploy. So we're going to deploy a sample database application. Actually, I'm not in the right directory. If you do the git clone repository, and then you need to change it to the directory. Let me change it to the directory first. Now I'm going to run MySQL deploy. So shortly, the application will be deployed successfully. It might take a few more seconds. So once the application deployed, you will see from the OpenShift Web Console, you can see Yong-MySQL has been active here. If you want to verify the rest of the stuff like the pod status, you can verify as well. So for the purpose of this demo, I'm just showing you, we deployed a sample database, but we haven't loaded any data yet. What I'm going to run another command is MySQL load data. So what's going to happen here is we're going to create a database called DB for Yong1 and also create a table including only one record here. So employee name, employee ID, and the location. So I loaded the data here. What I'm going to do next is we're going to we need to create a backup policy to back up this MySQL database and then export to the location profile. So let me come back here to Kasten Web Console. So the moment we deployed Yong-MySQL, you can see I got, Yong-MySQL. That's the application we already discovered here. First of all, we need to create an object storage location profile. If I go to settings here, I can create a new profile. I give a name, let's say S3, and I can choose Amazon S3. And you need to provide an access key, secret key, your region, your bucket name, etc. Once you've done all of these, you click Save Profile. I don't want to expose my secret key, access key, so it can be fully automated. So what I'm going to do is I just run the automation scripts to create a location profile, migration S3 location. So by doing this, if I come back to the dashboard, do a refresh, you will see my location profile has been created successfully. It might take a few seconds to load. Sorry, my network is a little bit slow here. So you can see my AWS 3 migration location profile has been created successfully. It was running from a US East 2 region, and this is my bucket name. Once I create all of these, you can go back to the dashboard. And then from my dashboard, you can select the application. So let's say this is my application, Yong-MySQL. You can click create a policy. And from here, you might want to make a few selections. So once I select create a new application, new policy, you already give a policy name. You can decide how often you want to do the snapshot. You can even make it, every 5 minutes. If you choose advanced options here, I might just leave it as a default. And very importantly, you need to enable backup by snapshot exports and select the export location profile, my AWS 3 migration. Once you've done all of these, you can click create a policy. Before I click create a policy, click YAML, it actually allows you to automatically generate the YAML file for you. So instead of creating the policy from your UI, you might end up with multiple mouse clicks. You need to enter all the selections. So I might just copy a YAML file, and then technically, if I cancel here, you can run the automation scripts, which I already created here. OCP3to4 MySQL migration policy. I'm going to run this policy now. So what's going to happen here is not only I'm going to create a backup policy, I also kick off the on-demand backup jobs. If I come back to the dashboard here, do a refresh, you can see my backup policy has been created. So it will do the snapshot every hour. For the testing purpose, I'm not going to keep longer. I only keep 4 hourly, 1 daily, 1 weekly. That's all I need. Go back to the dashboard. You can see my backup jobs has been kicked off. So shortly will be completed successfully. Let's actually, that is so fast, 24 seconds, the snapshot job has been completed successfully. Now we're going to automatically kick off the export job. So the export job basically copy all of these to the object storage bucket. It also completed successfully. So once we've done all of these, now let's go to my target cluster. So remember, from my target cluster, I also did a search. This is OpenShift Container Platform 4.7. This is a web console. From our projects, I did a search Yong. I can't find anything. Same thing from, this is a Docker background. That's, my target cluster. I was running from OCP, 4.7. From applications, I did a search Yong. I can't find MySQL applications. What we need to do from the target cluster, same thing, go back to the settings, create a location profile. Again, I'm not going to create a location profile from the UI. What I'm going to do is, again, I create the migration location profile, run these scripts. So we will create a location profile here. Too bad, my jump host disconnected. Let me, log into the jump host again. Okay, I just logged in back on my jump host. As you can see from here, I was running 1.20 from my target cluster. That's 4.7, OCP 4.7. Since I was running from AWS Cloud, that's why you can see the GP2 storage class. I was using GP2 CSI storage class. In the meantime, I also have a OpenShift container storage or OpenShift data foundation installed as well. I also did a search OC, get namespace. I can't find a Yong here. So first task, we're going to create a migration location profile pointing to the same storage bucket. That's where we can read the data from my source cluster. So the job has been completed successfully. I'm going to do a refresh here. So you might remember we're using US East 2 region. This is my bucket name ending with 0918. So my storage bucket has been created successfully. Now what I need to do is just create an import policy to import the data from my source cluster running from 3.11. Remember my target cluster was running 4.7. So what I'm going to do here, we're going to create a new policy. Let's say this is my SQL migration, okay? Let's make it easier to remember. Let's say OCP3to4 MySQL migration. So this time action type, it's not a snapshot, it's import. So very important. How I can access my source backup. So I needed the token code from my source cluster. Let me come back to my source cluster. Under the policy, from the policy settings, there is a show import details. Copy the token and then paste to my target cluster. Okay, it discover your location profile, the same thing, my AWS3 migration. So by doing this, we only allow you to read the data. But what about my, application containers? I want to restore, bring up the containers. So here we allow you to restore after import. Very importantly, yes, it's very important. You might have noticed, we are using GP2 CSI from my target cluster, but my source cluster was running on, Cluster FS. So we need to apply the powerful transformation to allow you to be able to restore from the target cluster. So let me add a false transformation here. So you can change the storage class. By changing the storage class, we allow you to restore to the target cluster, GP2 CSI. Okay, I created the location transformation to transform the storage class. And in the meantime, let me create this transformation first. So what I can do here is I will also transform another object. Yeah, by the way, the transformation is very powerful. So I'm going to come back to my source cluster just to show you. From my source cluster, if I do OC get port of my source cluster, you will notice I got a 2/2. So that means from this port, I got 2 containers. Because from the older version 1.11, OCP3.11, there is no CSI driver. You can't leverage the CSI driver to do the snapshot. So what's going to happen here is we are using the generic volume snapshot. We have the sidecar injected to this particular port to do the snapshot jobs. But from my target cluster 4.7, I already have the CSI driver. Why I still need the sidecar injected to the port? So I don't need that particular sidecar. So part of the transformation, I will remove that sidecar. Okay, come back to the target cluster. I'm going to add another transformation. And this time, let's say this is a sidecar remove. Let me call it a remove sidecar. Okay, what I'm going to remove? I want to remove the stateful set. Stateful sets. It's part of my MySQL stateful sets. My stateful set's name, it's called MySQL. You can verify from your source cluster anyway. So I'm going to create a new operation. The operation we're going to do here is we're going to remove the sidecar. So you need to get the details, the JSON, path of your sidecar. So I got the location here. So from here, basically, we're going to transform this by removing the, the first container. It starts from 0. Your original container is starting with 0. The number one, actually, that's your sidecar. So I'm going to remove this sidecar. I'm going to add the operation, create a transformation. So now I only did 2 transformations. It's very powerful. Technically, you can transform any one of your source spec artifacts. So I just transformed my storage class. I transformed my stateful sets by removing the sidecar. The other thing we can do is remember from my source cluster, I was using Cluster FS. So all the configurations recover to my target cluster, actually, it's not going to be helpful. Basically, it's useless. What I can do is I can exclude the recovery of the whole storage class configurations. So I'm going to add the whole group. So once I complete all of these settings, so you can select the on-demand. You want to do the one-time migration. So you might want to use that one as a standby DR. In this case, you might want to set the frequency. Again, you can make it every 5 minutes. So for the purpose of this migration, I'm gonna just leave it as on demand. Once I've done all of these, by the way, you can automate these by creating YAML file to run from a command line as well. So for now, let me create the policy. So it's on demand, it's not going to run automatically. So what I'm going to do here is I will run this command manually. Before I run this command, I want to show you the progress. So from the command line, what I'm going to monitor here is I will run this command. We're going to monitor the custom IO namespace and also Yong-MySQL namespace. Now I'm going to run this job. So let me run this job. Yeah, again, I want to just double check from OpenShift Web Console. If I do the search of the project Yong, I can't find anything. Let's see. Run once, run policy, go back to the dashboard. I can monitor the progress from our dashboard, OCP3to4 MySQL migration. And then I can come back to my command line to say, so we already kick off some of the jobs here. You can see checker procedure report. That's the temp report. We're going to verify the connectivity to the S3 bucket. And then we're going to bring up the affinity port to create the PVC. And after that, we're going to restore the containers. So you might have noticed affinity port is up running. And now we once the job finished, we will terminate the checker repository ports and then restore data container just to kick it off. Okay, it just becomes running. Once the job finished, we're going to restore the production containers. In this case, MySQL database, it's container creating status. Shortly, it will become running. And after pass the readiness check, it will become 1/1. So let's wait a few more seconds. It should be up running, just within a few seconds. Okay. Actually, the affinity port, it's terminating. And now let me come back to the dashboard. Let's see what's going on. Yeah, custom web console, you can see the job details. My first job, import job, completed successfully. My second job, restore job, is up running right now. And for now, if you go to OpenShift Web Console, if you go to the workloads, you can see the namespace has been created or project has been created. If you go to the workloads, check the ports, and select the namespace Yong-MySQL, you will see it is actually already up running. 1/1, not only running and also passed the readiness check. If I go back to custom web console to confirm, yeah, the job is wrapping up. So shortly should be completely successful. So you can see it take 2 minutes, 12 seconds. The migration from one cluster to the other has been completed successfully. Now, if I go to the terminal, you can see it took like 67 seconds. Yong-MySQL already up running here. Okay, now let me just do a verification of MySQL. Yeah, by the way, all of the scripts are available from my GitHub page. So let me just run this command to see. Yeah, so the same table, the same, same rule, Yongkang here, that's the employee name, employee ID #1, and the location Singapore. So that means we already migrated MySQL application from a source cluster to the target cluster. If you do a OC get the namespace grab Yong, you can see it just created three minutes ago. If you get all of the namespace, you can see I got MySQL port containers running, almost 2.5 minutes ago. If you get the PVC, you can also see the PVC was using GP2 CSI. Okay, that basically completes the the demo how quickly you can migrate one particular application or containers from 3.11 to 4.x. So in this case, I was using 4.7. But it should work for 4.8 or 4.9, but I never got the chance to test it, all of the different versions yet. What else? Let me just come back to my slide deck here. Okay, just to summarize the use case here. So the application mobility or portability, it's more about to enable the cross-cloud portability or migration of application between two different Kubernetes clusters. For OpenShift, the same thing. Even customers running still very old version, 3.11, that's like 4+ years ago. We still allow you to move your containers from 3.11 to the latest, not really the latest, to 4.7, which is pretty recent. And technically, you can try 4.8 or 4.9. And with this application mobility, allow the customers to run in some of the application in a hybrid environment. Could be keep some running on-prem, some of these running from the public cloud. And to allow easily to move from between public or private cloud Kubernetes deployment. And the three key major use cases here to simplify the upgrade maintenance. It is very very problematic or painful if you do the in-place upgrade of 3.11 to 4.7. There are definitely it's not going to work. There are a lot of challenges. By doing this way, we just do the snapshot of your 3.11 containers and then move to the newer version, 4.x. And we already tried the powerful transformation engine to transform a lot of different Kubernetes, objects, resources. Yeah, to allow you to easily move application between, test dev environment and the production environment. So I'm going to including a few reference links here. My automation code, it's available from a GitHub page. It's publicly available. And the Kasten Documentation, and also there are some, Kubernetes free training. You can collect all these cool badges here. And if you are interested, you might want to join the Kubernetes user group. So kasug.com. And there is another Kubernetes data management group, kasdm.com. Additional, learning, you might want to try Kubernetes automation and plus protection. So far, I created 6 automation across 5 different public cloud. So basically, within minutes, you can spin up a Kubernetes cluster plus the containers are being protected. So on the bottom of the screen, there is a playlist about automation. So far, this is number 9 container migration video. That's pretty much all I want to cover for today. Yeah, thank you for watching. And if you find this is useful to you, please click like and share this video with your friends, with your, anyone might be, useful to them. And please feel free to connect me via any one of the ways listed here. Thanks for watching. Enjoy your day.